Chapter 5. Analyzing Vulnerability Scans. Penetration testers spend a significant amount of time analyzing and interpreting the reports generated by vulnerability scanners, searching for vulnerabilities that may be exploited to gain a foothold on a target system. Although scanners are extremely effective at automating vulnerability identification, the results require interpretation by a trained analyst. In this chapter, you will learn how penetration testers apply their knowledge and experience to review vulnerability scan reports. Reviewing and interpreting scan reports. Vulnerability scan reports provide analysts with a significant amount of information. Beyond the high-level summary, scanners provide detailed information about each identified vulnerability. Let's look at a Nessus report, section by section. At the top of the report, you see the vulnerability name and its overall severity, expressed as low, medium, high, or critical. Next comes a detailed description of the vulnerability, explaining the flaw and why it matters. Then the solution section tells you how to fix it. The See Also section provides references for more details. The output section shows the verbatim data returned by the remote system when probed, which is invaluable for understanding why the scanner flagged a vulnerability and for identifying false positives. The Port and Hosts section identifies which servers and services are affected. The Vulnerability Information section includes miscellaneous details, and the Risk Information section provides the CVSS score and overall risk factor. Finally, the plugin details tell you which scanner plugin detected the issue. Other scanners like Qualys and OpenVAS follow a similar pattern, though the visual format may differ. Understanding CVSS. The Common Vulnerability Scoring System, or CVSS, is the industry standard for assessing vulnerability severity. It provides a technique for scoring each vulnerability on a variety of measures, helping analysts prioritize response actions. CVSS includes 4 sets of metrics. Base metrics measure the inherent severity of a vulnerability. Threat metrics include features that may change over time. Environmental metrics represent characteristics specific to your organization's operating environment. And supplemental metrics provide additional insight. For the exam, you need to know the base metrics, which are divided into exploitability metrics and impact metrics. The 5 exploitability metrics are attack vector, attack complexity, attack requirements, privileges required, and user interaction. Attack vector describes how an attacker would exploit the vulnerability. Values range from physical, where the attacker must touch the device, to network, where the attacker can exploit it remotely over a network. Attack complexity describes the difficulty of exploitation. High means specialized conditions are required. Low means no specialized conditions are needed. Attack requirements describes conditions on the vulnerable system. None means the attack will likely succeed against any reachable vulnerable system. Present means specific conditions must be in place. Privileges required describes the account access needed. High means administrative privileges, low means basic user privileges, and none means no authentication is required. User interaction describes whether another human must be involved. None means no user action needed. Passive means the user performs some action perceived as innocuous. Active means the attacker must get an authorized user to take specific, conscious action. The impact metrics assess the impact on both the vulnerable system and subsequent systems using confidentiality, integrity, and availability scores. Confidentiality measures information disclosure. None means no impact. Low means some information is accessible, but the attacker has no control over what. And high means all information is compromised. Integrity measures information alteration. None means no impact. Low means some modification is possible, but the attacker has no control. And high means the attacker may change any information at will. Availability measures disruption. None means no impact. Low means performance is degraded. and high means the system is completely shut down. The CVSS vector uses a single-line format to convey all metric ratings. For example, a vulnerability with a network attack vector, low complexity, no requirements, no privileges required, passive user interaction, high confidentiality impact on the vulnerable system, and low integrity impact would have a vector reflecting those values. The CVSS 4.0 calculator at first.org converts this vector into a base score. CVSS base scores are categorized into risk categories: none for 0, low for 0.1 to 3.9, medium for 4 to 6.9, high for 7 to 8.9, and critical for 9 to 10. Validating scan results. Cybersecurity analysts must confirm each vulnerability reported by a scanner. This may be as simple as verifying a missing patch, or as complex as manually simulating an exploit. When verifying, analysts should draw on their own expertise and the subject matter expertise of others throughout the organization. Vulnerability scanners aren't foolproof. When a scanner reports a vulnerability that exists, it's a true positive. When it reports a vulnerability that doesn't exist, it's a false positive. When it fails to report a vulnerability that does exist, it's a false negative. False positives waste testing time and, in the worst case, may alert administrators to penetration testing activity. False negatives can leave real vulnerabilities unaddressed. Scan completeness involves verifying that the scanner has effectively assessed all intended targets. A complete scan requires that all network segments, systems, and applications within scope have been covered, that the scan has been conducted with sufficient privileges for full evaluation, and that scans are scheduled at intervals aligned with the organization's risk tolerance. Troubleshooting scan configurations is essential when results seem incomplete or inconsistent. Public exploit selection. When a vulnerability has a publicly available exploit, penetration testers can use it to validate the vulnerability and demonstrate its impact. Exploit frameworks like Metasploit provide pre-built exploits for common vulnerabilities. However, testers must consider the stability and reliability of public exploits and should always validate results through their own testing. Using scripting to validate results. Custom scripts can validate scanner findings by probing target systems directly. For example, a Python script using the requests library can test for SQL injection by sending crafted payloads and analyzing responses. Scripting allows testers to confirm vulnerabilities in ways that automated scanners may not fully verify. Common vulnerability sources. Let's review common vulnerabilities you'll encounter on scans. Server and endpoint vulnerabilities include missing patches, unsupported operating systems and applications, buffer overflows, privilege escalation, arbitrary code execution, insecure protocol usage, and debug modes left enabled. Missing patches are among the most common and easily corrected vulnerabilities. Unimport operating systems and applications no longer receive security updates, making them persistent risk sources. Buffer overflows occur when an application writes data beyond the boundaries of a buffer, potentially allowing code execution. Privilege escalation allows an attacker to gain elevated access beyond their intended level. Arbitrary code execution lets an attacker run unauthorized commands on a system. Insecure protocols like Telnet and FTP transmit credentials in clear text. The solution is to use encrypted alternatives like SH and SFTP. Debug modes provide detailed information about application internals that can assist attackers. They should only be enabled in dedicated development environments, never on public-facing systems. Network vulnerabilities include missing firmware updates, SSL and TLS issues, DNS misconfigurations, internal IP disclosures, and VPN issues. Network devices require regular firmware updates from manufacturers. Outdated SSL and TLS versions should be disabled in favor of TLS versions 1.2 and 1.3. Insecure Insecure ciphers like RC4 must be removed. Certificate problems include name mismatches, expired certificates, and unknown certificate authorities. DNS servers are common attack targets. DNS amplification attacks use spoofed requests to bombard targets with oversized responses from DNS servers worldwide. Internal IP disclosure occurs when servers leak their private IP addresses in HTTP response headers, revealing internal network configuration details. VPN services must be fully patched and configured with secure ciphers. Virtualization vulnerabilities include virtual machine escape, management interface access, missing hypervisor patches, and virtual guest and network misconfigurations. VM escape allows an attacker on one virtual machine to intrude on resources assigned to another. The hypervisor management interface must be tightly controlled and never directly accessible from public networks. Virtual guests require the same security attention as physical servers, and virtual networks need virtual firewalls and proper segmentation. Internet of Things devices introduce unique challenges. They often run embedded systems or real-time operating systems, and patches may be difficult to obtain. IoT device manufacturers may not provide automatic update mechanisms, making vulnerability scans critical for discovering available updates. Web application vulnerabilities include injection attacks and cross-site scripting. SQL injection occurs when an attacker sends commands through a web server to a back-end database, bypassing security controls. For example, an attacker might search for a term containing an apostrophe and semicolon, breaking out of the original query and executing a second query that retrieves customer data. Protection requires input validation and least privilege on database access. Cross-site scripting, or XSS, occurs when an attacker embeds malicious scripts on a trusted website that execute in the browser of unsuspecting visitors. Input validation helps prevent XSS attacks. Summary: vulnerability scanners produce significant data that informs penetration tests. Testers must interpret scan results and prioritize vulnerabilities as attack targets. CVSS provides the standard scoring framework. Watch for false positives and false negatives. Know the common vulnerability sources: missing patches, buffer overflows, privilege escalation, insecure protocols, SSL and TLS issues, DNS misconfigurations, virtualization vulnerabilities, and web application flaws. Exam essentials. Be able to explain how vulnerability scan reports provide critical information to penetration testers, including severity, exploitation details, and suggested solutions. Know the purpose of CVSS and its base metrics. Understand the difference between true positives, false positives, true negatives, and false negatives. Be able to name common vulnerability sources and explain how virtualized infrastructures add another layer of potential vulnerability.